Okay, so for practice 1, we're just going to do factors of the constant divided by factors of the leading. So that's what we do to find potential rational zeros. So, factors of 14 over factors of 3. So that's going to be 1, 2, 7, and 14 on top over 1 and 3 on the bottom. And then we just have to write those all the way out. So I'm doing 1 divided by 1, 2 divided by 1, 7 divided by 1, so many numbers, 14 divided by 1, then we'll do divide by 3. So we'll have 1/3, 2/3, 7/3, plus or minus, and 14/3. And we wouldn't put any repeats if there happened to have been any. So we'll do the exact same thing. It's going to be factors of 12 over factors of 6. There's going to be lots of repeats in this one because these are highly divisible numbers. So we're going to have 1, 2, 3, 4, 6, and 12 up top, divided by 1, 2, 3, and 6 on bottom. So, oh boy. All right, 1, 2, so we basically just rewrite the top ones because we're always going to divide by 1 at first. And now I'm going to divide by 2, so I'm going to have 1/2. 2 divided by 2, already on the list. 3 divided by 2, not on the list yet. 4 divided by 2 is 2, on the list. 6 divided by 2, on the list. 12 divided by 2, on the list. So now I'll jump to 3 in the bottom. So I'll have 1/3, 2/3, 3 divided by 3 on the list already. 4/3 is not. Let's see, 6 divided by 3 on the list, 12 divided by 3 on the list. So now we'll do 6. So we got 1/6. 2/6 is on already, 3/6 is on, 4/6 is on, 6/6, and 12 over 6. So these, I didn't need to go on the next line apparently, are our answers. There we go. So here there's 2 ways to approach this one. So we can first make a list of all of what we just did, right? So I'm going to do factors of the constant divided by factors of the leading. And so that's going to give me plus or minus 1, plus or minus 2, plus or minus 1/3, and plus or minus 2/3. So I really only have 8 numbers that I want to check from here. And I can kind of look over at the graph and say, hey, it looks like negative 1/3 is maybe a good one to check, and maybe 1 would be good ones to check. Not positive, but maybe. So we could either do f of negative 1/3 or f of 1 and see if they equal 0, because that would tell us that the remainder is 0, and that means they're factors. Or we could do synthetic division. I'm pretty confident about the 1, so I think I'm going to do synthetic division with it. And got to remember to put the 0 where the x to the third would be. Okay, so we'll bring the 3 down. 1 times 3, 0 plus 3, 1 times 3. Add, we get 7, 7, 2, 2, 0. Okay, so that means that x equals 1, definitely one of our rational zeros here. Now let's check negative 1/3 by just continuing on with the division here. So I'd bring the 3 down and do negative 1/3 times 3 is going to be negative 1. That's going to give me 2. Oh boy, numbers are going to get gross now. You can get 2/3. If I add 7, subtracting 2/3, that's going to actually give me 19/3, I believe. Oof. Negative 19/9. And then if I add this stuff, I'm going to end up with a negative 1/9. So that is not equal to 0. So that means that negative 1/3 is not going to be one of our rational zeros. And that means, because no other one looks close, I mean, we could technically check 2/3, negative 2/3 if we really wanted to, just because it's in the ballpark. But I think that we're pretty safe saying that this is the only rational zero that's going to exist. So that means that there's 3 other zeros that they're just not necessarily rational zeros, okay? From what we can see in the graph anyway. So they could have been jerks and like it could have looped back down maybe and hit somewhere else, but I don't think so. Right, 3, we just got to analyze this guy. So we're going to look for all the things we like to look for. So first I'll start off by saying what the degree is. So it's a degree 4. That means my max turns could be 3. And let's find our end behavior. We're going to use kind of our bootleg way of doing it. So it's negative, so our right-hand side is down, and it's an even degree, so our left-hand side will also be down. So we're going to be going down, down. Let's find x-intercept. So I'm going to set y equal to 0. I'm going to factor out a negative 2x squared, which is going to give me an x squared minus 2. And that's going to give me 0 with a multiplicity of 2 from the x squared, and it's going to give me a plus or minus the square root of 2. And all I did was just set the x squared minus 2 equal to 0 in order to get that. Both of those have multiplicity of 1. So I'm going to plot those. I need to estimate where I think the square root of 2 is. So what I do for that is I do square roots I know. So I know the square root of 1 is 1, and I know the square root of 4 is going to be 2. And since the square root of 2 is somewhere in between 1 and 4, the square root of 1 and the square root of 4, that means that I'll be somewhere in between 1 and 2. So that's why I was able to put those points there, just as a nice little estimate. Have my end behavior is pointing down, so I can draw down, down. And honestly, this is enough work. If we really wanted to, we could plug in some extra points just to make sure. So if we plugged in like 1 and negative 1, and I would just evaluate the function at those values. And for both of them, we end up getting 2, because this is a nice even function, which means it's symmetric. And then I can kind of connect the dots. So I'm going to cross, I'm going to bounce off of that one, and cross, and connect down to my end behavior. So I knew I was bouncing because of the even multiplicity, and I knew I would cross because of the odd multiplicities. Super important to note, right? We have no idea how high these are, or their specific x value. So we just don't know those things until we learn calculus. So we don't care. All right, 4, basically we would jump back to the example to see what all of the steps were that we found before. So we would start off by looking for potential zeros. Then we would use the graph to narrow down those potential zeros. Then we would use synthetic division to test/factor. And then if we wanted to, we could use the quadratic formula or just factor by any method possible to keep reducing it all the way until we get factors and ultimately zeros. So let's start off. We're going to do factors of 8 divided by factors of 2. So that's going to be 1, 2, 4, and 8 over 1 and 2. So if I simplify that into our new thing, right, we always just get the top because we're always dividing by 1 at first. That's a plus or a minus. It's a little messy, sorry. So now we'll do divide by 2. So we're going to have 1 divided by 2, not on the list yet. 2 divided by 2, on the list. 4 divided by 2 is 2, on the list. 8 divided by 2, on the list. So these are only our potential ones. So now let's take a look over here and say which ones do we think work. So I think that could be a negative 1/2 right there. This one looks like it could be 2, and this one looks like it could be 4. So I think that we should check 4, 2, and negative 1/2. And it doesn't matter which one we start with. I'm just going to start with 2, just for fun. And then we're just going to synthetically divide. Okay, so I'm just doing synthetic division here. And hopefully not messing up the math as I do it, because you know me. Math isn't always my strong suit. Okay, that worked perfectly. Yay. So let's check 4 now. I guess, wait, let me do my summary form that I've been doing for us, where we say, hey, this is what we have so far. We have x minus 2, what we divided by, and then we have a 2x squared minus 7x minus 4. And if we wanted to at this point, we could just factor 2x squared minus 7x minus 4, because we could just use the AC method and we'd be done. But because we have 4 as a pretty likely candidate, I think it's easier for us to just do synthetic division one more time, especially because we end up getting it to work. And if I do my summary statement now, I have that x minus 2 from before, the x minus 4 that we just divided by, and we're left with a 2x plus 1. So this thing is fully factored now. So that's actually one part of the problem, right? It said write it fully factored. So done. And now what we want to do is say what the zeros are. So our zeros are going to be x equals 2, 4, and negative 1/2, which happened to be exactly what we guesstimated from the graph. But that's basically the process that we go through every single time. So let's do that again for 5, just to make sure that we're feeling good and see if maybe this one's a little bit different. It looks like it's much bigger. We're going to have 4 answers here. So let's do factors of 6 over factors of 6. Really original questions here. So we're going to get 1, 2, 3, and 6 on both top and bottom, and then we just got to clean that up, which I think there's going to be a lot of cleaning up. We're going to end up with a lot of numbers here. So we get 1, 2, 3, and 6 just from doing divide by 1. Now when we do divide by 2, we'll get plus or minus 1/2. 2 divided by 2, 3 divided by 2, not on the list, so 3 divided by 2. 6 divided by 2, already on my list. 1 divided by 3, 2 divided by 3, 3 divided by 3 on the list, 6 divided by 3 on the list. 1 divided by 6, not on yet. 2 6 is on, 3 6 is on, and 6 6 is on already. So here's my ginormous list of all possible ones. And when I'm looking, I see a couple that are pretty clear to me. I think 2 is a pretty good one, and I think right there is -1. These other ones, I think it's just too risky for us to try to guess what's going on with these other values here. And realistically, because it's x to the 4th is what we're starting with, if I can divide it twice, that will reduce it to an x squared, and then I can factor or use the quadratic formula. So I don't really need to keep going with it. So we'll just do synthetic with one of these. So we'll do 6, -13, -8, 17, and 6. So it's going to be 6, 12, -1, -2, -10, -20, which is -3, which is -6, and we get a big old 0. So that means that so far what we have is x minus 2, and then a 6x to the 3rd minus x squared minus 10x minus 3. If we thought we could be successful with factoring by grouping here, we could, but I don't think we would be, so I'm not going to. Let's check -1 off of this now. That's basically trying to further factor this second part. So we'll get 6, -6, -7, 7, -3, +3, and we get a nice big old 0 there. So we now have f of x equals that x minus 2 that we already had, an x plus 1 from what we just divided by, and our last line, 6x squared minus 7x minus 3. And I think what we want to do now is we'll focus on factoring this. So I'm going to factor by the AC method. So I'm going to do what multiplies to 18 and adds to 7. So that's going to be a -9 and a +2. So if I just keep doing this lovely math here, we'll just get this stuff. So I'm going to get 3x plus 1 and 2x minus 3. And then I still have the original x minus 2 and x plus 1 from above. So this is the fully factored form, because we have nice linear factors for everything, and our zeros are going to be x equals 2, -1, -1/3, and +3/2, all of which were up on our list of potential zeros way up here at the top. So we could have probably guessed. I underlined the wrong one, kind of embarrassing. Let's make that go away. This one. And where is the 1/3? This one. So we could have potentially guessed those, but it was too wishy-washy for us to, and it was easy enough to just factor. Hope you found this useful, and I will catch you in the next one.